So let's look at some math that we're going to look at consistently throughout this course. And one of the big pieces we're going to use a lot in physics is algebra. Algebra is really the basic language of physics, and we're going to use a lot of algebra and really build on your algebra skills. The important thing about solving a problem using algebra in physics is that when we are working with an equation, we are always going to solve for the unknown variable first using our rules for algebra, and then if we have numbers, substitute those known variables in. So let's look at our first example here. We want to solve for a in f equals ma. So if we take this equation, f equals ma, remember, ma is the same as m multiplied by a. If we remember our algebra, to get rid of something that is multiplied by another value, well, we just divide both sides by that value. So m divided by f on one side and ma divided by m, that allows us now to cancel out the m's and get a all by itself. Now we can rearrange the equation. Because it's an equation, it doesn't matter which we write on either side. We usually write the isolated variable on the left. So that tells us that a is going to equal f over m. There's our equation solved for a. So let's try another. In E equals mc squared, we want to solve for c. Well, we start with our equation, E equals mc squared. And like before, we're trying to get the m to the other side, so we divide both sides by m. That'll cancel it out. And we're left with c squared is equal to E over m. Now the only thing about this is we're not looking for c squared, we're looking for just c. And again, if you remember back to previous math courses, well, to get rid of a squared, we just take the square root and we just do the same to both sides. Square root of c squared leaves us with just c. And on the other side of the equation, we have the square root. Remember, we always have to consider when we do a square root a plus or minus e over m. And there is c solved for in E equals mc squared. Well, what if we have an example where we have numbers? And this is where it goes back to solving for the variable first. We have an equation, v is equal to d divided by t. And we want to solve this for d and then put some numbers in. Well, if you remember from solving equations, as long as we do the same to the left side and the right side, we don't change the equation. So we need to get rid of this t on the bottom. So we just multiply the right side by t, and as long as we do the same to the other side, we don't change the equation. Well, now the t's will cancel out, and again we can write d on the left. That's going to equal t multiplied by v. d equals t times v. So now we can plug in our values. Our t is 8.0 seconds, and I'm going to put it in brackets to get rid of that dot, and we're going to multiply that by our v of 36 meters per second. And now we just turn to our trusty calculator and multiply 36 times 8, which will give us 288. And if we look at our units, we have seconds in the top multiplied by a meter per second, and our units will actually cancel out because what we're going to end up with is 288 meters. There is our answer with our proper units and our values. And we're going to do a lot of algebra and a lot of solving for equations. The other thing we're going to review is trigonometry. And we're going to do a lot of trigonometry in this course as well. Remember, trigonometry deals with right-angled triangles. And when we have a right-angled triangle, we know that the two legs of the triangle, the sides, are A and B. The longest side is always C, our hypotenuse. So for any right triangle, whenever we're trying to solve for a side, we're going to use our good old Pythagorean theorem of a squared plus b squared is equal to c squared. If we have two sides in a triangle, we can find the third just by using Pythagoras. Well, we can also solve triangles using trigonometry. And if you remember from trigonometry, we start with a right angle triangle. From any angle, and this angle we're going to call theta, from that theta there are three sides: an opposite side, an adjacent side, and a hypotenuse. Again, opposite is opposite, looking across at the angle. Adjacent, it means it's right on top of the angle, and the hypotenuse is the longest side. And when we have a right triangle, we can use SOHCAHTOA, our trig identities. And these trig identities, if you remember, three forms. Sine of the angle is opposite over hypotenuse, cosine of the angle is adjacent over hypotenuse, and tangent is opposite over adjacent. So when we are trying to find an angle or a side on a triangle, if we have two pieces of information, we can find the third. Well, let's use this information to actually solve this triangle. And there's a lot of ways we can solve this triangle. Remember, to solve the triangle, that means we have to find every angle and every side. So the first thing I'm going to find is I'm going to find this unknown side, which I'm going to call B, because I know I'm going to use Pythagoras. A squared plus B squared is equal to C squared. Well, we have the hypotenuse and we have the adjacent, so we're trying to solve this for B. And to solve this for B, well, we first start by taking A to the other side. We're going to isolate for B. So C squared minus A squared, and our B value. Now we can consider the positive. We know it's a length, so we don't have to consider the negative when we do the square root of C squared minus A squared. And of course, then we plug in our numbers. C squared is our hypotenuse of 12 meters, and we're going to square that value, and we're going to minus 8 meters as well as squaring that. And when we put that in the calculator, plug it all in, multiply it all out, we'll get 8.9 meters. That's the length of the unknown side in this triangle. And now that we have that length, we can find the angles in this triangle. So let's find now this angle, which we're going to call theta. And theta, doesn't matter which angle we find first, we're going to find that value theta. The key though here is we always want to use the data that is given. Yes, we found one side is 8.9 meters, but we always want to use the data that's given. In this case, that means we have the hypotenuse and we have the adjacent. If we look back to our trig ratio, that tells us we are going to do the cosine of the angle, because cosine is adjacent over hypotenuse. So cosine of the angle, the adjacent in this case is 8 meters, and the hypotenuse is 12 meters. We want to find the angle, and if you remember from previous math courses, now to find the angle, what we have to use, it's what's called the inverse cosine, the cos to the -1 of this number. Now you'll have to check on your calculator to see how you type that into your own calculator. Sometimes you have to put the value in first and then cos to the -1. It's called the inverse cosine, but when you do plug that all in, what you should get is 48.2 degrees. And we can take that angle and write that on our triangle. This is 48.2 degrees. And now the only thing left to solve on this triangle is this third angle, which I'm just going to call alpha. Now what we have to remember to solve the third angle is that in every triangle, all the angles add up to 180 degrees. So if we want to find alpha, that unknown third angle, we just take 180 degrees, that's all the angles in the triangle, and minus what we know. One corner is the right angle, which is 90 degrees. The other corner is what we've just found, 48.2 degrees. And if we subtract all of those from 180, we get 41.8 degrees. This is our third angle. That now allows us to have our triangle solved because we found every angle and every side. And we're going to do a lot of trigonometry using those 3 trig ratios throughout this course.